Thank you very much for the warm welcome. I'm really excited to be here, really more excited than usual because my talk proposal had to be in the waiting list and was accepted 2 days ago. And I was converted to speaker officially after I arrived at the conference venue. So I'm really glad to be here. Right, so let's start the talk titled as, Democratize serverless web AI apps for Python devs. I am Yuichiro Tachibana, coming from Japan, who is a software developer who uses Python for several types of development, as well as I am also enthusiastic to OSS contributions. I actually have some contributions to OSS activities. So please find me online using searching for this username, WHITPHX. Right. The first question I'd like to ask in this presentation is, what do you use Python for? Obviously, I know each of you has different and diverse answers to this single question, but particularly in this talk, please focus on the fields such as data processing, machine learning, or AI, LLM, things like that, and web development, or things like that. I know this is kind of an opinionated choice of application field of Python, but I also believe that these are some of the most most popular application field of Python, actually. And you are Python developer, or at least you know Python somehow. So you have a power to order Python to do something automatically, just like what this famous book, Automate the Boring Stuff with Python, proposes. For example, like in your daily business days, you can write Python script to process CSV files or generate some reports based on the result of that processing, or process something else, or just even do some more complex tasks that emerges in your daily business life. Although there are some dedicated tools, frameworks to do some specific tasks, but this is true that writing Python script is the best, or at least suboptimal solution for your daily task in your real office life. So let me provide one example. Please assume that we have some data, sales data, formatted as a CSV file, and we have to extract some information or insights from this kind of table data just by writing Python scripts. By the way, this is just a mock sample CSV, so you do not have to take a closer look into each line of this data, but just assume that we have some table CSV data. So what you write in Python is something like this. You will read read CSV file into data frames like this, then process data with some methods, blah, 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 then write the result back to another result file so that you finally get some result CSV file. This is some practical implementation example, but this is a bit long, so you don't have to take care of each line of this implementation. Just let us take a rough look at some lines of this implementation. For example, like when we execute this script from terminal, this script will read a CSV to pandas data frame, and this process sales data function takes the data frame and applies some processing. You don't have to take care of the details anyway, but some processing, like applying some functions or data processing, blah, blah, blah. Then the script finally writes the result back to the CSV file. And as a bonus, this also prints some statistics or some sample rows of the process data to the standard output. So obviously, if you run this script, then it outputs some statistics, like the statistics of the sales data, for example, like top 10 states by revenue, like this, and some sample CSV here. And you also get the full portion of the processed CSV table data. Well, this is great, right? Like, just by writing only Python script, you get a power to process the sales data in your office, in your company. But the problems come, there will be some problems when you want to share this power. You want to hand over this processing script to your non-tech teammate or some sales team sitting next to your seat, or your boss, manager, or even your clients, because obviously this is a terminal script. Well, this is very often that you want to share this kind of script with your non-tech colleagues, so that they can run trial and error cycle with a higher cadence, and for them to get a better understanding of the data. So what comes to our mind when we are thinking something like that is just to convert our script into web application that is shareable and that provides some interactive UI to manipulate, to interact with data, that is easy to use and easy to understand what it displays. So when we think of something like this, there are several different types of tools that you can choose. One option is to use server-side Python frameworks like FastAPI, Flask, or things like that. But if you take this path, you have to write front-end application alongside. Another option is to use some notebook frameworks. Jupyter Notebooks is a famous one, and recently Marimo emerges. Anyway, in this talk, let me choose another option, that is web UI frameworks, pure Python web UI frameworks. That web UI framework that includes frameworks such as Streamlit, Gradio, or things like that. Right. Of course, you have a freedom. It is, depends on your purpose or your preferences. But particularly in this talk, let me choose this specific one, Streamlit. Streamlit is a type of framework, so-called pure Python web UI framework. Streamlit converts the Python script you write into a web application that has some interactive widget or some visualization widget that shows insight or data based on your input data. For example, again, this is a sample, so you don't have to take a closer look into it. Anyway, if you write some Python script like this and run Streamlit run command in the terminal, you will get access to the web-based application, including some visual and interactive widgets that showed various types of data or chart, graphs, or tables, or blah, blah, blah. So the next idea we will get is to use Streamlit or some frameworks like that to add on such web UI on top of the data processing script we have written in the previous chapter. Because we already have a data processing script that has it doesn't work well so much, but anyway. We already have a data processing script that has a single entry point function, process sales data that takes the data frame as an input, process something, and returns the data frame as an output. We can simply import it from the script file that we have written in the previous chapter into the new Python file for the Streamlit application, and we simply write some new UI definitions. In this case, I would like to add file uploader so that this application will get the input CSV file from the user, and if user uploads something, it reads the uploaded file into data frame, and the data frame will be fed to the data processing function that we have imported from another file. Then I also add the download button that allows the users to download the result, the final result and CSV file into their local. Just by writing this less than 30 lines of Python code, you can get this kind of a fully functional web application where users can upload CSV files, and process the data processing. We have implemented the previous chapter, and the user also download the final result CSV to their local, just like this. This is the power of, this is a benefit that Streamlit provides. And we now have a web screen to display some visual widgets, as we have seen, so we can, as an extra bonus, we would like to add some more widget to display something else, like this. If you upload something, I added some metrics widget to show some statistics that had been printed into standard output. It was just a boring visual, right? But just by adding some small amount of Python code to define this kind of UI widget, we can get visually appealing web applications that probably useful to negotiate with your clients or bosses based on your data or your processing or your business logic. Right. So now that we have been discussing about creating web application on top of data processing, but at this point, let me take another look in another direction, that is empowerment of your data processing pipeline with AI or LLM or things like that. Obviously, nowadays, AI is an inevitable topic to discuss, right? By using AI, you can add on some more intelligent data processing things to your script, or even more capabilities to deal with more forms of data, including text, image, or blah, 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 things like that, that we have never been able to process with in the traditional method. In this talk, again, let me take very opinionated choice of library. In this case, I would like to use Transformers library. But I think this is not a very fair choice because Transformers is one of the most famous or popular Python library to access the power of AI or LLM models from the very useful unified API. But after installing Transformers with pip, you can get access, you can use various types of AI models that processes different types of unstructured data like text, image, video, audio, or even multimodal thing. We don't want to focus each of the modality in this short period of time, but the core message of this slide is that you have some possibilities to deal with this kind of various type of data with your script. In this presentation, I would like to provide one or two examples of usage of Transformers library. In this code snippet, we import the pipeline object from Transformers library and initialize it with the task type called sentiment analysis, passed as the first argument of the pipeline object. Then you will get the instantiated pipeline called sentiment analyzer here that judges if the given text sounds positive or negative. It's a very emotional task. If you provide text like "I love LLM," that actually sounds positive, the sentiment analyzer pipeline output the result actually this given text sounds positive. All right, so the next thing we would like to do is just to integrate this kind of our AI pipeline into the data processing pipeline we have read in the previous chapter. One good example is that, the target data, the data we expected to be input is the sales data that contains some customer feedback written in the English text. So one interesting application of AI in this case is to judge if the customer has a negative or positive feeling against our sales team. So this code, we initialize the sentiment analysis pipeline like the example just in the previous slide, and we will apply the sentiment analysis processing to each data in its data in customer feedback column that will be stored in the sentiment column. By processing, by running this pipeline, thank you, 10 minutes, okay. By processing pipeline, we'll now get a new insight, new type of insight extracted from the sales data that had never been able to get without AI. For example, like this says the positive feelings has 173 counts, but negative feedback against our sales team still have 27. So this is a very interesting application of AI pipeline in our processing. And as we have seen in the previous example, our Streamlit application simply imports the core logic in a separated Python file, so we can just use the Streamlit application we have written just before with very slight modification. It doesn't work well, so sorry. All right. But in this case, well, now we have an ability to get some sentiment analysis statistics results from our processing script. I added the metrics Streamlit widget to show the sentiment analysis result like this, so that now our dashboard has metrics about positive feelings of our customer against our sales team. So you can say to your colleague that your score is about 86.5. And I wonder if you have some questions like, why do I choose transformers instead of some using API-based LLM capabilities that some proprietary providers like OpenAI or Anthropic provides? Of course, it depends on your purpose or restrictions, but in our case, data privacy is one priority because our sales data has some data that can be considered credential or secret. So I would like to process our LLM in our local machine so that they never send such credential data to any remote servers. All right, so this is the final section of our presentation. We have been looking at some, AI integrated data processing pipeline, but next step is to convert that web application to be serverless one. One typical example where this kind of things is desired is that when you want to share this application's counterparts, even outside your organization, because they sometimes have more strict privacy requirements in their organization so that they cannot upload any data to remote servers. Or even from your perspective, you do not want to keep managing your server to serve such a web application. So this is where the concept of serverless comes to our mind. The word serverless sounds a bit vague, but like in this very specific context, it means something like client-side execution or in-browser execution, which means that the serverless web application does not have any server-side runtime, any server-side Python runtime installed on your web server. As a result, all logic will be loaded into your browser and executed within your browser. Therefore, no data input by the user never sent to the remote server, which is very good characteristics of being serverless to keep users' privacy. As I said, being serverless has some benefit like privacy, and in addition to that, the low latency or offline capability is also there. And from the perspective of service providers, scalability and cost efficiency is also good benefits. But one question is that Python runs on the server usually, right? Like, what makes it possible to run Python in our browser? The answer is the software called Pyodite. By the way, unfortunately, there is another talk is going on about Pyodite with this very same time slot. So this is unfortunate, but please check out the recorded talk of that, the recorded video of the talk after this my talk, if you're interested in this topic, by the way. By using Pyodite, that is CPython compiled to the WebAssembly target, which sounds a bit techy, but in short, it is simply a Python that can run inside a browser, which sounds a bit weird, but like it's real. It's really working. And some WebViewer framework families, including Streamlit, have their siblings that utilize Pyodite instead of Python so that they can be executed inside your browser. We have been using Streamlit, so let me take an example of it, whose sibling of WebAssembly is Stlite, aka Streamlit-Lite. The usage of Streamlit-Lite, Stlite, is very simple. The thing you have to do is just to create a single static HTML file and add some lines of code to JS and CSS file from Stlite library that you can copy from the repository's README. Then you will add special HTML tag saying a Streamlit app, and you can put the Python code just inside this special HTML tag. Although this looks a bit crazy and weird, but like it's actually working. And now we have an in-browser version of WebUI framework, but what about LLM? Don't worry, like transformers have LLM, transformers also have in-browser version, in-browser sibling. Transformers is a Python library, as we have seen in the previous slide, and it has JS version that enables to run, that makes it possible to run machine learning model into the browser. And here is transformers.js.py that makes it possible to access the power of transformer.js from in-browser Python, aka Pyodite, which sounds a bit like a joke, turning a circle 360, but it's real. Sorry, let me skip this slide. So by combining all of these technologies, by adding very special tag requirements to list up requirements in our Stlite or serverless Streamlit applications to specify transformers JS library into our serverless Streamlit app, we can finally get a single HTML-based serverless AI application just by putting all the Python code into this HTML file like this. Here is the actual one. Sorry, this is a bit small, but like this is just a single static HTML file. And if you open it, the process, now we have a Streamlit-based application where you can upload some CSV files to here, and every expected output is actually here. But again, this is all embedded into static HTML file, which means serverless or static application. So let me wrap up what we have been walking through in this talk. We have created Python script to process some data at the very first phase. It was very great for our personal use, but it's a bit difficult to be shared with our non-tech colleagues. So we created web application based on that script by using Streamlit or you can choose any other families of web UI frameworks for get similar outcome. Anyway, then as a final ultimate goal, we converted this web application into serverless version. This sounds a bit extreme, but this actually has some benefit like data privacy or easy server management, cost efficiency, or things like that. So you can realize it by using frameworks like Stlite, aka Streamlit-Lite. This kind of disclaimer that the tech stack, the choice of technologies what I have explaining in this presentation is a bit opinionated, but I promise that this is very useful for fields like data processing, data analysis, visualization, machine learning, or things like that, that are very specific field where Python has a strong ecosystem. So Python is very often used for. But at the same time, this kind of field sometimes has priority or important consideration about data privacy or data transparency, model control, cost efficiency, or things like that. So making them serverless could be a good option to meet these two types of requirements at the very same time. All right, so this is my last slide to wrap up my own. So I am thankful very much for listening to my talk. I'm Yuichiro Tachibana. Thank you very much. And some frameworks appeared in this talk was actually what I have been developing. So please check out and contact me if you find something. Thank you.
Okay, thank you for your talk. And are there some questions? Please use the microphone. There is a microphone if you have some questions. Okay, I will take our microphone.
Hello, thank you, and congratulations for your talk.
Thank you.
And for being able to have it in 2 days. You mentioned that Transformers has a JavaScript version, so you can use it in the browser. For example, I have a project where I have to use Excel files. You can use also other libraries in the browser for that?
Excel file, you mean not CSV? Good question. Sorry, I don't have a clear answer right now, so let me discuss it later. It depends on the availability of Excel, availability of Python libraries that read Excel file on pile at runtime, so I have to check it. Oh, really? He said the answer is yes. Probably he has OpenPy Excel. Great, thank you. Probably he knows something.
Okay, next questions? Is there somebody next who has some questions? No? Okay. My colleague gives you a microphone.
Yeah. Thanks a lot. Very interesting presentation. I was just wondering, how do you keep track of different package versions when you make an app like that? Because normally in Python, maybe you require a specific version for your application. So how do we make sure that the serverless app doesn't break after some time because something has been updated?
Sorry, let me confirm that you're asking about the package versioning in the case of serverless.
Exactly.
Yeah. Great. Thank you for asking that. There is not so much sophisticated way to manage package version in browser Python ecosystem actually, but it's just like requirements.txt thing. There is no log file, but you can add some version specifier in this list, just like requirements.txt. Could it be the answer to your question?
Yes, thanks.
Thank you.
Okay, next questions? Or it's everything? Okay, so there's no more questions. Thank you very much for the amazing topic.
Thank you very much.
See you in the venue.